Okay, so we're on part two of the video. This part is about solving absolute value equations. So first question here, what is absolute value of 8, or what is the absolute value of 8? Well, our answer to this is that it's positive 8 or negative 8. Because what absolute value is really asking you is what expression inside is a distance away from 0 of, in this case, 8. So when we're talking about absolute value, we are talking about finding a value that is a distance from 0. So for this problem here, this is saying what x values are a distance of 8 from 0? Well, there's two numbers that are 8 away from 0, positive 8 and negative 8. So the second question, what does the absolute value of 3x plus 4 equals 6 mean? Well, what this is saying is what what x value would make this expression of 3x plus 4 a distance away from 0 of 6? And so once again, there are two values that are a distance of 6 away from 0, 6 and negative 6. And so what I'm trying to do here is figure out how can this expression of 3x plus 4 that's inside my absolute value equal either the 6, or how can this expression of 3x plus 4 that's inside the absolute value equal negative 6? Because if it's equal to either of those two things, then its distance away from 0 is 6. And so if I solve each of these, subtracting 4 from both sides, I get 3x equals 2, not negative 2. And so x would be 2/3. And if I solve here, I would have 3x equals negative 10. And I divide both sides by 3, and I would get negative 10/3. Now, just to kind of check this, if I plugged each of these solutions back into the equation, I would have 3 times 2/3. Well, 3 times 2/3 is 2, and 2 plus 4 is 6. Well, the absolute value of 6 is equal to 6, so that checks out. If I have x equals negative 10/3 and I plug that in for x, I would have 3 times negative 10 over 3, which gives me negative 10. Negative 10 plus 4 is negative 6, and the absolute value of negative 6 is 6. Okay. We do need to check for any extraneous solutions in our original equation. I just plugged both of those back in and checked, and they both worked out, but there will be some times that that doesn't work. Primarily that happens when we have a variable outside of the absolute value sign. So here's another problem. We have the absolute value of 2x minus 11 plus 8 equals 13. Now if you're solving something like this, you want to isolate the absolute value sign first and what's inside of it. So if I'm going to isolate the absolute value of 2x minus 11, that means I need to subtract the 8 on both sides. And so that gives me the absolute value of 2x minus 11 equals 5. So I'm trying to find a value of x that will make the expression 2x minus 11 be a distance of 5 away from 0, which means I'm interested in finding what will make 2x minus 11 either equal 5 or negative 5. So if I solve, I have 2x equals 16. Divide by 2 and I get x equals 8. Over here, if I add 11 to both sides, I would get 2x equals 6, and therefore x would equal 3. So let's check these. 2 times 8 would be 16. 16 minus 11 would be 5. The absolute value of 5 is 5, and 5 plus 8 is 13. So that one checks out. If we have 3, 2 times 3 is 6. 6 minus 11 is negative 5, but the absolute value of negative 5 is 5 plus 8 equals 13. And so that one also checks out. So both 8 and 3 are solutions. All right, so our next problem is the absolute value of 7x minus 5 equals negative 8. Check to see that the absolute value sign is isolated, so there's nothing on the left side of the equation but that absolute value, so it is isolated at this point. So this is saying what value of x would make the expression 7x minus 5 a distance of a distance away from 0 of negative 8. Well, we never talk about distances as negative values, and so if you have something like this, your absolute value is never going to be able to be equal to a negative number. And so there's actually no math that we're going to do here. We just want to identify that there is no real solution to this problem. It is not possible to have an absolute value equal to a negative number. So nothing else to do on that one but to say no real solution. Okay. So our last absolute value example here is the absolute value of x squared minus 5x, and then we're going to add 4x to that, and it's equal to 6. So we need to isolate the absolute value once again, meaning that we're going to have to subtract 4x on both sides. So that gives me x squared minus 5x inside the absolute value equals 6 minus 4x. And it's a little bit more complicated because we have multiple terms that this absolute value is equal to. So when we think about taking this expression and thinking about what it could be equal to, this expression of x squared minus 5x, if it's equal to 6 minus 4x, that could make both sides equal and our distances the same. Or I could have x squared minus 5x be equal to the opposite of what was there, which was that 6 minus 4x. So notice that I have a negative sign out in front, and I've put what was on that right side in parentheses. So I want to try and solve each of these. I have a quadratic, and because there's a quadratic, I'm going to set it equal to 0 by moving all the terms to one side. So that would mean I would have x squared. I'm going to need to add 4x to both sides, so I'm going to just be left with a minus x, and then a minus 6 equals 0 for this. This quadratic can be factored. Looks like it can be factored into x minus 3 times x plus 2. And so when I solve each of these, I get x equals 3 and x equals negative 2. Over here, I've got x squared minus 5x equals negative 6 plus 4x. Once again, we've got a quadratic. I'll move everything to one side. So I have x squared minus 9x plus 6 equals 0. So if I'm looking to try and factor that, I'm looking for numbers that would multiply to be 6 and add up to be negative 9. Nothing comes to mind, so we need to find another way to solve this quadratic, and so we're going to complete the square. So I've got x squared minus 9x plus something equals, and I'm going to move that constant term to the right side of the equation, so equals negative 6. So to complete the square, I need to take half of negative 9. So I'm going to write that as negative 9 over 2. We square that, and so squaring negative 9 over 2 gives me 81 over 4. I need to add that to both sides. So with our rules for completing the square, this perfect square trinomial, it's got a fraction in it, but that's okay. It's going to factor into the same binomial, so we're going to have a binomial squared. And so we have x minus 9 halves. Remember that this constant value in this binomial is always half of the original b value. I'm going to make a common denominator here, so I'm going to have negative 24 over 4 plus 81 over 4. If I combine those together, that gives me 57 over 4 on the right side. At this point, I'm ready to take the square root of both sides. So on the left side, I have x minus 9 halves equals plus or minus. Here, I do have a perfect square of 4, so I'm going to write this as the square root of 57 over 2. And so my final step would be to add 9 halves to both sides. So I have x equals 9 halves plus or minus the square root of 57 over 2. Another way that we could write that is x equals 9 plus or minus the square root of 57 all divided by 2. Now, we are going to check for extraneous solutions. Just for time purposes, I won't check this 9 plus or minus square root of 57 over 2, but I will check the 3 and the negative 2 that were part of the first side of the equation here. So if I take 3 and I plug it back in for all my x's, that would give me 3 squared, so 9. Let me write this out here. Minus 15, that's inside of the absolute value, plus 12 equals 6. So this ends up being the absolute value of negative 6 plus 12 equals 6. So 6 plus 12 equals 6. 18 equals 6. Doesn't look right. Not equal. This is an extraneous solution. If I try negative 2, negative 2 squared is 4. If I multiply negative 2 times that 5, I'm going to end up adding 10 plus 4 times negative 2. So I'll end up with a minus 8 equals 6. Well, here I've got the absolute value of 14 minus 8 equals 6. Absolute value of 14 is 14. 14 minus 8 is 6. 6 equals 6. I'm in good shape there. Okay. What I would probably suggest doing for the 9 plus or minus square root of 57 over 2 is storing that value on the calculator, plugging it in, and seeing if you get the equation to come out to equal 6. Okay. But that's how we would check for our extraneous solutions. Okay, so that's the end of the notes. There's the homework. I'll see you next time.